Hey everyone, welcome back to my number sense series. In this video we're going to talk about divisibility rules. That is, rules to tell if any number is divisible by some other number, like 2, 4, 5, and 8. By the end of this video you should be able to look at any number and instantly tell, or tell very quickly if it is a multiple of 2, 4, 5, or 8. But these ideas are built upon something that are like fundamental ideas of divisibility. So we should go over those first, but don't worry, it's not going to take too long. They're pretty intuitive, I would say. So there are basically two main ideas, but really they're kind of one main idea. If a and b are divisible by n, that is their multiples, if n divides evenly into a and b, then it will also divide evenly into a plus b, a minus b, and a times b. For example, if we have two multiples of 5, 50 and 15, if I add them, they're going to be 65. If I subtract them, they're going to be 35. And both of these results are still multiples of 5. If I add and subtract two multiples of something, two numbers that are both divisible by n, then the end result is still going to be divisible by n. Also, if I multiply them, this equals 750, which is also a multiple of 5. And if you know a bit about prime factorization, this is actually kind of two multiples of 5, because it's a multiple of 25, actually. And, well, technically it's also a multiple of 125, but that's because I chose 50. Now, similarly, if a is divisible by n, and b is not, then a plus b and a minus b will not be multiples of n, or not be divisible by n. For example, 50 and 13 would be 63. And 50 minus 13 would be 37. And so you can see, if I take a number that is divisible by n, and I add or subtract a number that is not divisible by n, then my end result will be like tainted. It won't work because this thing is messing it up. However, a times b will still be divisible by n. For example, 50 times 13 is 650. And this is still divisible by 5, because this 50 will not get canceled out by the 13. And this is something that you will understand later when we talk about prime factorization if you don't right now. Now, final note, just because two numbers are not divisible by n does not mean that if you add them or you subtract them, they're not going to be multiples of n. For example, take 12 and 13. 12 is not a multiple of 5, 13 is not a multiple of 5, but if you add them together, you get 25, which is a multiple of 5. That is to say, you can't really say anything conclusive about a plus b or a minus b if both of them are not multiples, because it's possible that some nice thing could happen or some cancellation could happen, and you will actually get some number that is divisible by n. Now, hopefully that wasn't too boring, because we're now going to move on to the actual tricks. So 2 is a very, very simple trick. In fact, 2, 4, and 8 are all built upon the same idea. And 5 also, basically. And the idea is to decompose the number. For example, if I give you a number 1397, how can you tell if this number is a multiple of 2? Well, I'm sure a lot of you know the divisibility trick for 2 already. It's just look at the last digit and see if it's an even number, right? But why? Why is that true? Well, it's because 1397 is like 139 times 10 plus 7. We're decomposing this number, and the critical thing to notice is that if it's times 10, then this is already going to be a multiple of 2, because it's 139 times 5 times 2. And now, since we know this part is a multiple of 2, if we want the resulting number to be divisible by 2, then this should also be divisible by 2. And that's why we can just look at the last digit to determine if something is divisible by 2. Because if it is divisible by 2, then our whole number will be divisible by this rule. And if it's not divisible by 2, then our whole number will not be divisible by this rule. A very similar idea actually applies with 4. If I make up a number right now like 2, 3, 7, 6, 8, we can't do the 10 thing this time because 10 is not divisible by 4. But we can do a 100 thing. This is actually 23700 plus 68. So you can see here now we're actually separating out the last two digits. And this is because we will get a 100 here. And 100 is 25 times 4. And so that's how we can tell that this part is also a divisible by 4. So we can just look at the last two digits and see if these are divisible by 4. 86, is it divisible by 4? Oh, sorry, this should be 68. Is 68 divisible by 4? It is, and that's how we know 23768 is going to be divisible by 4. For 8, it's going to be a very, very similar idea. Can you guess? Instead of doing 10 or 100, we do 1,000 this time. So we look at the last 3 digits. For example, 1, 2, 3, 4, 5, 6, 7, 8. If I take this number, I will decompose it into 1, 2, 3, 4, 5, 0, 0, 0, plus 678. And what this gives me is that the first number is divisible by 8. I know it's divisible by 8 because it ends in 0, 0, 0, because it's a multiple of 1,000. So it's 1, 2, 3, 4, 5 times 125 times 8 plus 678. So now because this is automatically a multiple of 8, I can just look at 678 to see if my whole number, my entire number, is divisible by 8. Is 678 divisible by 8? The answer is no. So this entire number is not divisible by 8. And I can tell that, once again, just by looking at the last 3 digits. Now 5, basically the same idea as 2, because if I can decompose something like this, it also applies here. This logic, I also have a 5 here. So actually, I can also just look at the last digit for 5. For example, if I give you a number 1995, this is 1990 plus 5. In other words, 199 times 2 times 5 plus 5. So this number is going to be a multiple of 5. So it all depends on if this number is divisible by 5. And I'm sure you knew this trick already, but this is how we actually prove it. And it also extends, as you can see, 2, 4, 8, and also bigger numbers like 16 and 32 and 64. But when you get too big, it starts to get inconvenient, which is why we only talk about 2, 4, and 8, because you're restricting yourself to smaller numbers, so it's much easier to do. But you could also do this with any power of 2 or 5 that you wanted. So in summary, here are our divisibility rules. For 2, look at the last digit. For 4, look at the last 2 digits. For 8, look at the last 3 digits. And for 5, look at the last digit. These are pretty easy to prove and even easier to memorize and apply, so hopefully that really helps you guys. But also they are built upon our fundamental ideas of divisibility and really number theory in general. So please try to understand these as well, why they work, and that will serve you very well in other math and beyond. So thank you guys so much for watching. That's going to be it for today. I hope it was helpful, and I'll see you next time.